Okay, next problem in the Z transform. Here we are going to solve the problems based on our input given. Okay, here we are going to use the properties of Z transform. Based on the properties, we will be finding what is the Z transform for the given input signal. The first problem is going to be find the Z transform of the signal x of n is equals to u of minus n. This is a given equation. We know that the u of n, the Z transform is going to be, we already find out this equation how we will be getting of the Z transform for our unit step function. The Z transform is going to be 1 divided by 1 minus Z inverse, where mod of Z is greater than 1. Here u of minus 1 n is there, means this is of a time reversal property. We have to use time reversal property. What is the time reversal property is going to be u of minus n is going to be, where is Z inverse is there, that Z is going to be taken as inverse of that, means 1 by Z. Therefore 1 divided by 1 minus 1 divided by Z power minus 1, where our mod of 1 by Z is greater than 1. Here u of n, the Z transform is going to be 1 divided by 1 minus Z, u of minus n, this is minus n, 1 divided by 1 minus Z, where mod of Z is less than 1. This is one problem. Next problem is of find the Z transform of the signal x of n 3 into 2 raised to n u of minus n using appropriate properties. Given, write the given equation. Then what you have to do, based on the what is the u of n function it is given. Here it is of minus n, it is given u of minus n. Based on that we have to modify the 2 power n. What the modification I can do? I want to represent the n, the time varying function. It should be in terms of minus n, because u of is of minus n. If I write 1 by 2 power minus n is nothing but 2 raised to n only. For that reason, I just modified the 2 raised to n as 1 by 2 raised to minus n u of minus n. Okay, then what is 1 by 2 power n u of n? The Z transform is going to be 1 divided by 1 minus 1 by 2 Z inverse. Therefore, mod of Z is greater than 1 by 2. Then how you will be getting of this, that I shown here. You have to use your Z transform equation, put x of n as 1 by 2 power n u of n, apply the limit based on the u of n function, then use the formula. You will be getting as 1 divided by 1 minus 1 by 2 Z inverse. The region of convergence 1 by 2 Z inverse is less than 1. Therefore, mod of Z is greater than 1 by 2. What you will be getting of. Then here is of what? U of minus n. So which property will be going to use? Here we have to use time reversal property, so that I can write as 1 divided by 2 power minus n u of minus n. The Z transform is going to be 1 divided by 1 minus 1 by 2 Z. What you did here, just we changed here we changed 1 by Z power minus 1. This is nothing but Z only. For that reason, directly written here as Z. Then by using the linearity property, which we have to multiply here, 3 is also there, that we have to multiply here. Therefore 3 1 by 2 power minus n u of minus n, Z transform is going to be 3 divided by 1 minus 1 by 2 Z. You will be getting off. The next problem, using appropriate property, find the Z transform, that is x of n is equals to n square 1 by 2 power n u of n minus 3. Here where you are going to change the n value is going to vary for u of unit step is of n minus 3. What you have to do, you have to change this n value as n minus 3. What's the modification I can do? Just I did here 1 by 2 power 3 this n square written as it is. Then 1 by 2 power n minus 3. If I multiply these two, what I will be getting? I will be getting of only 1 by 2 power n only. 1 by 2 power n minus 3. U of n minus 3 you will be getting of. Then 1 by 2 u of n, already we come across that the z transform is going to be 1 divided by 1 minus 1 by 2 z inverse, where mod of z is greater than 1 by 2. Then using shifting property n minus 3, right? What I can write? The z transform is going to be z, how much the shift is going to be? Minus 3 times. So z raised to minus n naught. N minus n naught it is, but here n naught is having the value as 3. So I can write as z raised to minus 3 divided by 1 minus 1 by 2 z inverse. Therefore, if I simplify this, then I will be getting as 1 divided by z cube minus 1 by 2 z square. Then observe here n square it is there. Means we have to differentiate the z transform equation twice. Here using differentiation in z domain property, then only one time. For that reason n I am taking now. N 1 by 2 power n minus 3 u of n minus 3 z transform is going to be minus z d divided by dz of 1 divided by z cube minus 1 by 2 z square. This is the property. If we have to differentiate this, then if you differentiate, we will be getting as minus 3z square plus 1 by 2 2z divided by z cube minus 1 by 2 z square, that whole square. Then multiplying here, then we will be getting as 3z cube minus z square divided by z cube minus 1 by 2 z square power square. This is only for n is going for, but in the equation it is given n square. Means we have to use the differentiation again one more time. Again using differentiation, then I can write as n square 1 by 2 power n minus 3 u of n minus 3. The z transform is going to be minus z. This you have to take again. This you have to differentiate again. That is minus z d divided by dz 3z cube minus z square divided by z cube minus 1 by 2 z square power square. Then go for differentiation, you will be getting as z power 4 9z square minus 5.5z plus 1 divided by z cube minus 1 by 2 z square, the whole cube you will be getting off. Then one more is what it is left again here. 1 by 2 power 3 is there. What I can write? 1 by 8 I can write. Using linearity property, just you go for 1 by 8 n square 1 by 2 power n minus 3 u of n minus 3. The z transform is going to be multiplied the whole with 1 by 8. That's what here it is written. The next problem is of find the z transform of the signal x of n is equals to n into sine pi by 2 n u of minus n. Which are properties we can use here? Here it is of time reversal. Here it is of time differentiation. This is a given equation that here it is written. Then here sine minus pi by 2 n, because u of function is in terms of minus. Whatever the problem it is given, first you have to check what is the unit step function it is in terms. It's either it is minus n or n minus 3 or any of the other properties is that is going to be used for our unit step function. First you check that. Based on that you have to modify the whole equation. Simple maths, if just apply there you will be getting off that. Okay. Then x of n minus n. Again minus of minus, it's going to be plus only. For that is a minus n sine minus pi by 2 n u of minus n is nothing but the same equation. Okay. Then z transform of sine pi by 2 n dot u of n is going to be sine pi by 2 z inverse divided by 1 minus 2 cos pi by 2 into z inverse plus z raised to minus 2, where mod of z is greater than 1. Then here sin pi by 2 is going to be 1. Then what is the remaining part? Substitute for cos pi by 2 also 1. Then you will be getting as z inverse divided by 1 plus it will be 0, z inverse divided by 1 plus z raised to minus 2. Then this I can write as z divided by z square plus 1. If I do that simplification, what the simplification you can go? Instead of z inverse, I can write as 1 by z. Instead of z raised to minus 2, I can write as 1 divided by z square. Take the LCM and do the modification. You will be getting as z divided by z square plus 1. Then using differentiation in z domain, then n sin pi by 2 n u of n is going to be minus z d by dz of z divided by z square plus 1. Go for differentiation here. I hope you can do that. You'll be getting, after simplification, you'll be getting as z cube minus z divided by z square plus 1. That whole square you will be getting out. This is what the solution for the given problem. This is very important. All the problems are already asked. This is it. This question is asked few more times for 6 marks. Next, after this, still it's not completed. Why? Because we got only for the positive, but here it is of a reversal, right? For that reason, using time reversal property, minus n sin minus pi by 2 n u of minus n, where our z should be replaced by 1 by z. Z cube minus z divided by z square plus 1, that whole square. Wherever z is there, that you have to take as 1 divided by z. That you have to substitute here. Again go for simplification. You will be getting as z into 1 minus z square divided by z square plus 1 whole square, where mod of z is less than 1. Then find the z transform of the signal. X of n is equals to 1 by 2 power n u of n convolution with 1 by 3 power n u of n. Here we are going to consider the first part as x1 of n and second part as x2 of n. Let x1 of n is going to be 1 by 2 power n u of n. The z transform is going to be x1 of z is equals to 1 divided by 1 minus 1 by 2 z inverse, where mod of z is greater than 1 by 2. Then x2 of n, we are considering of this part here, 1 by 3 power n u of n. The z transform is going to be x2 of z is going to be equals to 1 divided by 1 by 3 z inverse mod of z is greater than 1 by 3. What is the convolution property is telling for us? The time domain convolution, when we go for the in the z domain, it's going to be the multiplication. The convolution in time domain, it is going to be changing. If I go for z transform, that is going to be a multiplication. For that reason, what we have to do, if I want the z transform of x of n, the x of z is going to be, just we have to multiply x1 of z with the x2 of z. If I multiply these two, I'll be getting as 1 divided by 1 minus 1 by 2 z inverse into 1 minus 1 by 3 z inverse. This is the simplification. This problem will be asking for 4 marks. The next problem is of given, that is x of n. The z transform is going to be x of z, that is equals to z divided by z square plus 4 with the region of convergence, mod of z is less than 2. Using z transform properties, determine z transform of the following signals. The first here it is given as y1 of n is equals to 2 power m x of n. Then y2 of n is given as n into x of n. First we will consider here a y1 of n is equals to 2 raised to n x of n. For us, the x of n z transform it's given as x of z is equals to z divided by z square plus 4 with region of convergence, mod of z is less than 2. Using the scaling in Z domain property, we can scale that y1 of n is equals to 2 raised to n x of n. The scaling property is going to be y1 of z is equals to x of z divided by 2 based on the scaling property. Keep in mind, here we are not going to be using of, here it is not like u of n, right? Here for the input signal only, we are going to be scaling by 2 power n. Then therefore that is equals to capital X z divided by 2. Okay, means the z domain, what is the x of z is of z divided by z square plus 4. Now we have to replace z as z by 2. For that reason, z is taken as z by 2, and here also z is going to be replaced as z by 2 whole square plus 4. Go for simplification here. They will be adding as 2z divided by z square plus 16. Therefore, mod of z is less than 4. This is one thing. Then the next is given as y2 of n is equals to n into x of n. By using of the differentiation property, y2 of n is equals to n into x of n. y2 of z is going to be, what you have to do, minus z dx of z divided by dz. X of z is they only given for us, we should not find out of for that. What they given? Z divided by z square plus 4, that it is written here. Then do the differentiation here, then go on solving for this, and lastly you will be getting as y2 of z is equals to z3 minus 4z divided by z square plus 4 the whole square. This is the problem. Next problem is of determine the z transform of the following signal and sketch the region of convergence. Here the two problems, here it's given, a is given as x1 of n is equals to 1 by 3 power n, where n is greater than or equals to 0. Then 1 by 2 power minus n, where it is n is less than 0. And one more, it is given as x2 of n is equals to x1 of n plus 4. Now what you have to substitute? We have to go for both the positive and negative values also. Where n is less than 0 means the negative values, for that reason the negative values are going to be existing. For n varying from minus infinity to minus 1, where it is x of n is of 1 by 2 power minus n z raised to minus n, plus summation n varying from 0 to infinity 1 by 3 power n z raised to minus n. Then here we have to change the limit. So if I change the limit from n varying from 1 to infinity, the power is going to be inversed. Its whole is going to be in the power we have to multiply by minus 1. What it's going to be? Then if I do that, 1 divided by power n minus of minus plus, then z raised to minus of minus plus z raised to n you will be getting off. Then plus this as it is 1 by 3 power n z raised to minus n. Then write the powers in the common factor because both powers are same. 1 by 2 into z power n I can write from here, I can write as 1 by 3 z raised to minus 1 the whole power n. Then by using the formulas, I can write as, for the first term it's going to be 1 by 2 z divided by 1 minus 1 by 2 z plus 1 divided by 1 minus 1 by 3 z inverse. Take the LCM and go for the multiplication of in the reverse fashion. Then go for solving this, you will be getting as 5 by 6 divided by 1 minus 1 by 2 z into 1 minus 1 by 3 z inverse. Region of convergence is going to be, where you have to take the region of convergence here, 1 by 2 z less than 1, and then 1 by 3 z inverse less than 1. 1 by 2 z less than 1, 1 by 3, Z inverse less than 1. Therefore, mod of Z is, in this case, it's less than 2. Mod of Z here it is greater than 1 by 2. What I can write here, where our mod of Z is going to be existing in between 1 by 3 and 2. Within that limit, it's going to be existing. Next, this is for the question for the A. Next, B is given as x2 of n is going to be x1 of n plus 4. For this, a shift is going to be n plus 4. Means by using of the shifting property, x2 of z is going to be z power. What is the shift? How much the shift it's given? That is z power 4 into x1 of z. We already find out what is x1 of z. This is x1 of z. That you have to multiply with the z raised to 4. Just to multiply for this with the z raised to 4. That here it is written. 5 by 6 into z raised to 4 divided by 1 minus 1 by 2z into 1 minus 1 by 3 z inverse. What is the region of convergence? We already find out where it is going to be existing in between 1 by 3 to 2, and the region of convergence is going to be existing in between now 1 by 3 and also 2. This is it is shown in this figure. Next problem is of determine the Z transform of the sequence x of n is equals to n square into u of n. This is the given equation that is taken. Then what is the u of n z transform? It is of z divided by z minus 1. At least remember the z transform for the u of n. Okay. It will be easy for us when we are going to solve a few more problems further. Okay. Or else by using of the equation, go on substituting fastly and you can get this result also. Then which property we have to go for? We have to use the differentiation twice. Okay, using differentiation one time, so I can get as n into u of n, that is going to be minus z d divided by dz of z divided by z minus 1. Differentiate this, you will be getting as z divided by z minus 1 whole square. Again one more time, because n square it is there, for that reason minus z differentiation of this one, that is z divided by z minus 1 whole square. If you do the differentiation, you'll be getting, and go on simplifying this, you'll be getting as z into z plus 1 divided by z minus 1 whole power 4. Simplification easy. How much it is possible you go on doing. Okay. Then next problem is of find the z transform of the signal using appropriate property, that is x of n is equals to minus n alpha raised to n u of minus n minus 1. This is the given equation. The z transform of minus u of minus n minus 1 is going to be z divided by z minus 1. Here, observe here, minus n is there. Using a differentiation property, what's going to be minus n u of minus n minus 1 is going, z transform is going to be minus z d by dz of this z divided by z minus 1. Then differentiate this, you will be getting as z divided by z minus 1 whole square. Then using scaling in the z domain, I can alpha raised to n is there, right? For that reason, what we can write here, where we have to substitute wherever z is there, that it's going to be changing as z divided by alpha. Wherever z is there, that is there you have to change as z divided by alpha. Here also z is there, z by alpha. Here also z is there, z by alpha. You have to substitute and go for simplification again here. Simplification has nothing but it is in terms of your z divided by alpha. You should get in terms of avoid the rational values, keep in a real values in terms of values I am telling. What I can do, take the LCM, what you will be getting, z divided by alpha divided by z minus alpha divided by alpha square you will get. This whole square you will be getting. This is going to be multiplying here. Therefore, 1 alpha get cancels. Z alpha divided by alpha z divided by z minus alpha whole square you will be getting off. That's it. Okay.